you're trying to explain or tell. So show that passion, so that should reflect. Okay. So here we're going to talk today about different type of applications. Hey, why we wanted to know about this? Different type of applications. Is it really required to know about this one? Boss, I ask you a simple question. Now I'm trying to cook a biryani. Do you don't you know that what type of biryani you need to prepare or what the ingredients you wanted to give it to that? Without knowing that, can you prepare a biryani? That's not a good idea, right? The same way, if you're going to test some application, if you don't know what type of application is that, then how do you test that? Will it be a good idea? Probably not. So first of all, you should know what are the different type of applications in the market. And always I'll try to give you some stupid examples and I'll give you the real-time examples also. Okay, don't worry about it. So why I give the stupid examples? Because this will help you to remember for a long time. And then I'll give you the real time how the people will implement or do the things also. Now, as I said that, so when you wanted to test an application, you should know what type of application is this. So now there are different type of applications in the market. So what are those different type of applications? Is one tier, two tier, three tier, and then four tier architectures. And the same one tier architecture can be called as standalone or desktop applications. Two-tier applications is called client server. Three-tier applications are called as web applications. Four-tier applications are called network distributed applications. And there is no separate layer, but all these people will call this one as the mobile applications too. So now, how this would be called as a one-tier, a two-tier, a three-tier, a four-tier. So to understand this one detailedly, so first of all, we wanted to know about one more topic, which is the ISO layers. So if you people are from the graduation, any particular graduations, so this is the first year, especially from engineering, I'm talking about it. But yeah, we will be having, this is a 16 marks question. So this usually we will do it. So we will just take that particular, just to, I think if you see this one, you'll be remembering this particular diagram. So this is the ISO layers. Right. So now when we have this particular ISO layers, we can see that physical layer, data link layer, network layer, transport, session, presentation, and application layers. So there are 7 layers which if you wanted to transfer something from one means of to the your system, so we will be having these particular layers which you can do that. I'll not go into the details of all these layers because it might confuse us. Now, as of now, we will take only the 3 layers which is important for us to understand. The 3 layers are, the first one is the presentation layer. The second one is the business logic layer. The third one is the database layer. So we take this particular 3 layers so that we can understand the things very clearly. Now, you go for a hotel. In a hotel, you go and order something. Now, you will be seeing the server, right? The server will come and he will take that particular order and then he will go back to the kitchen and he will say that, hey boss, I need some fried rice. So he will order that and then he will get it back and then he will serve for us, right? Now, this guy is a front end and the kitchen is the back end, right? So now he is a client facing guy and in the back end, he will be taking care of this. Example, another thing. In movies, we see our film actors, the hero, heroine, comedians, junior artists, supporting characters, and everything will be there. But background screen, there would be an editor, screenplay, director, a story writer, everyone would be in the back end. So for everything, we will be having the front end layer and the back end layer. Now the front end layer is nothing but what we see is called front end. You know, we see hero, heroines, comedians, right? And back end, we can't see them, but we know that those are the people who created this all. So now the same way for everything, we'll be having the front end and the back end. Now the front end, which we can see with our naked eye, so which is called the front end. So now this is called FE, front end, or this is called as client side, because this is from the client, means we are the clients, right? So we are seeing this one. So this is from the client side, and this is the back end. Okay, so which we can't see it. So then this is called back end, or this is called server side. Why it is server and all these things, I'll talk about that in the same session. So, okay, this is a server side. Okay, so now presentation layer is which is the UI, the front end UI, which you can see for anything. So now for an example, now I'm trying to open any particular websites and I'm trying to see here, I can see, hey, there are all these things are called as UI, right? UI is nothing but user interface, GUI or UI, graphical user interface. Now this is UI, right? Now what are these things all called as? So now here I have some buttons, I have some text boxes, links, buttons, check boxes, and all these things are there. Now what are these things are called? These are called as GUI objects. Okay, so with this particular GUI objects, I'm performing some action. So now I'm going to click on today's deals. So this is a link which it gives me what are the deals for today. And if I click on here, so I'm going to enter some text. So now I'm going to enter some text over here. So here I can get that. So now if I click this one, so I'll be getting this particular search activities. So this is how we will be interacting with the UI. So now this is what the presentation layer, which we can see and then we can interact with that particular things. Those are the things which it is called the presentation layer or the front end layer. So now if you see here, now this is what the presentation layer. Now what I did is I have just typed here now boxing clauses and then I started to search. When I started to search that one, I'm able to get this particular boxing clauses. Means in the back end, see, this is what the request I made and he got this one. Means if you see here, the same hotel example, now this is what I ordered for, the kitchen prepared me and then they send it back to me. The same way, I search for this boxing clauses, this take this request, it went back in, it got that particular information, and then it started presenting to me in front end. So now if I wanted to change now, so I'll just try to change this and see now as soon as I ask for shoe, then the shoes will be displayed for me. Means this is a request which I have been given to the server or to the backend. So the backend understands this one and give me the output whatever I'm looking for. So now if I'm giving it here for mobile, now it will gives me the mobiles here. See, the request and the response it was given to me. So now there is some logic. So now when I ask for mobiles, it should give me mobiles. When I ask for shoes, it given me some shoes. So this is what nothing but the backend or the business logic which we have been given for it. So the business logic is nothing but, hey, what is the logic here we have been used? The business logic here is, I'm searching for mobiles, it should display me the mobiles. I'm searching for the shoes, it should display me the shoes. I clicked on login button, it should be able to log in. So that would be your business logic. Awesome, right? Now, the next one is DB. DB is nothing but database. What do you mean by database? What do you mean by database? So
the area where we store the data, like
that's
files.
it. That's it. See now, for an example, where you store all your money, which is called as banks, right? Where you store all your documents, which is document repo. The same way, where you store all your required data, then that is called database. So it might be the user database, it might be the application database, or you can have a different type of databases. The basic purpose of the database is to store your data. That's it. Nothing much, nothing less. So that is how you will be having all these particular data will be stored. So now one is a presentation layer, one is a business logic layer, and the next one is a database layer. So now with these layers, we will be having storing this data. Why I'm discussing this one? So here, when we are talking about the application needs, that is related. Okay, how it is related is now, if at all I have all these things in a single layer, in a single place, in a single application, then this is called standalone application or the desktop application. Awesome, right? So now if all these presentation layer, business logic layer, BB layer, everything is in a single layer, then this is called as a standalone application or the desktop application. Now let's see the example here. So now we can see this, the simplest example is the calculator. I'm able to see the UI. Yes, yes, no, yes, no.
Yes, we can see.
Yes, sir,
can
we
see
can
it,
see.
right? Now, this is a front-end UI layer. Now, what I wanted to do, I wanted to give some 45 into 25. 125. See now, I have been given the log, the presentation layer. I have been clicked on it. So it's given me the output. See, the business logic is also ingredient into this one. So now you can multiply with anything. So now you can see that particular information over here. Now where this particular data is stored. So now if you see here, if I see here, all my data, whatever the calculations I have been performed. So first I have been done 45 into 125, and then I have been added 53 to that number, and then I added 5122. I added to that number. So this is how this particular data is stored for this particular calculator, and this is how the business logic is running, and the presentation is there. So everything into a single shot. Then this is called a standalone application or desktop application. Next one, the client server application. The client server application. What do you mean by a client and a server application for this? The client server application is nothing but you went to hotel. I give you the same examples to relate that one. Okay, so you hear the same example, right? So I went to the hotel. You are alone. Will 3-4 people will come and take the order, or 1 people will come and take the order?
Only one people.
Only one people. One people.
Okay. Now
One people.
we went 20 people went into the hotel. So 1 people will come and take the order, or 2-3 people will come and take the order?
2 people.
2 people.
3 people. It depends upon. Boss, they'll say that, boss, this is your table, and this is my table. This is that guy table. So for 5 people sat here, 10 people sat here, 5 people sat here. You take care of this table, I take care of this table, and this one. Now what here it means? The server, every server have a capacity to handle the customers. Even now here, the 10 people are there. So if 1 or 2 people here, they will try to handle all these particular 10 people. And here 1 people who are 5, 10, 5, right? 20 people. So 2 people means 5 people can handle one server can handle 5 people. Because without getting any delay. See, you imagine that for all 20 people, if there is 1 server, can he serve for all 20 people very fast? No, because everyone will give different orders. You need to go to the kitchen, bringing back that, it would be a problem. But for 20 people, if I have 4 servers, will it not be faster? Same logic here. Same logic here. The client server architecture is nothing but we will be having 1 particular server, and we will be having the multiple clients for this one, and then this server will support for all. So now actually if you see in our good olden days, we used to have internet caves. In the internet caves, we'll be having 1 particular server. If you wanted to make any particular printout, we need to ask, we need to send to that guy. So then he will take that particular printout from that printer, and then he will give it back to us. The same logic also, this is what the same thing, and this is the right example for the client server architecture applications. Means there would be having multiple clients connected to a single server, and server will hold that particular capacity of things, and then we will have multiple servers. So see, server 1, server 2. So this holds 5 people, this holds another 5 people. That's it. So now this is called client and server architecture. Now here, how this particular things will be distributed is presentation layer always will be in the client side, right? As we all know that from the client, so we will be having the presentation layer, so which we can see with your naked eyes and all the things. And DB and the business logic layer. So it may be into the server, but now the DB, the business logic may be into the client side or the server side, and even the DB may be in the server or in the client side. So they can shuffle it, but all things will be not there in the client side itself. Some of the things will be distributed to the server level also. Either it's a DB or the business logic, something they will be distributed into server side. But presentation layer could be on the client side. The example for this one is the internet caves, which I have been told. So because previously all our application types, even if you go for reservation counters, IRTC counters, previously it is used to have, it is in a local area network, so which is called as LAN. So LAN is called local area network, and WAN. What do you mean by WAN?
Wide area network.
wide area.
Wide area network.
So now this all things would be local, means this would be into the local area. This would be wide area, means throughout into the means completely external. So if you see here, this is called intranet, and this is called internet. The difference is you need to see it. So now this is intra, means it is internally to this. So now whatever the accessing which I wanted to do it, only these people can access that. Means something I wanted to access some files from this particular server, only these set of people can access this. Not from the external world can connect to this one. But whereas you kept it to the internet, this can be accessed by anyone else. For an example, there is some college websites are there. So that would be intranet. Whoever in that particular college, they would be accessing those particular websites. It is not exposed to the outer world. When it is internet, it can be accessed throughout the globe. You sit in Spain, Italy, Germany, wherever you go, from wherever the place is there, you would be accessing that from that particular place. So this is called WAN, and this is called LAN. In LAN, the supported protocol is intranet, and supported for WAN supported protocol is internet. Or supported technology is internet. Okay, so now in this particular client server architecture, we will be seeing that. So this is what the intranet, and which we use LAN, and this there will be a single server connected to the multiple clients, and presentation layer would be in the client side, and then from the server side it may have or it may not have the business logic or the database, the databases which can be stored. So now the database is nothing but it is very simple, guys. Don't think too much for the people who were thinking about the database means what. You would be having your mobile phones, right? In your mobile phones, you would be having your internal memory, external memory. What it mean? What it will do? You take pictures, you have some videos, all those things will go and store into that particular things. Same way, if you wanted to store some information related to the application, means for an example, now you're logging into the Amazon. So now your user credentials, user data should be stored, right? And your credit card details or whatever the addresses which you have been given, all that particular data need to be stored, right? So that storage will be done into this particular DBs. So same way now here they can store the DB in the server or somewhere else they want to store, they can store it. So this is what the client server architecture. So now if you see here, there are two tiers, tier 1, tier 2. So that's the reason it is called 2-tier. And here everything into a single tier, then this is called 1-tier architecture, standalone or desktop applications. Or here 2-tier architecture or client server applications. Any questions still here?
No, sir.
No, sir.
No, sir.
Hello?
Okay. Yes.
Yeah, so actually one question.
Mhm.
Can you please give another example other than internet cafe for client server relationship, client server architecture? Because there is no database in internet
Okay.
cafe, so I'm not able to get it fully.
Not a problem. So now for an example, nowadays the basic problem is this is old technology. No applications are there here. I give you the college example and then IRCTC example because these all everyone was converted into the 3-tier architecture now. I'll try to give once again the same example because there is no popular applications in the client server. All the things are migrated to the web as this is the old technology. Yeah.
Sir, I will
May
give
I
you.
tell something?
Yeah, please go ahead.
So how about the computer laboratory room set up in a college or something?
Yes.
So where it is connected via LAN, and it's an example for LAN, right? Intranet connection.
Yes. See,
Yep.
now I'll try to elaborate that one. So for an example, now we do have our computer labs, right? Even now the computer labs are migrated to the 3-tier architecture, but still I'll try to see that. So all my computers will be like this, round the room. So, and there are some computers in the middle. So now if you see here, from here, you can't access the internet. All these things has been connected to some servers. For an example, all the students will come here. Student 1, student 2, student 3, 4, 5, 6, 7, 8, everyone will sit here. For all these 5 systems, we have one server. And for all these particular 5 systems, I have one server. And for all these 5 systems, I have one server. And for the middle systems, I have one server. Now, the students will come and then they will access the presentation layer from each systems, and any business, any particular things to be stored, retrieve it back. So those things, they can store it into the server. A single server, they will be having it, and then they will be storing it. By the way, what do you mean by server? Don't think too much. Server is nothing but it's a physical machine with a high configuration. This is called server. The name itself, it was saying that it serves. If it is serving some client, then it is called as a server. So server is nothing but, see, now even our laptops also will be calling as a server. If it is a high configured and it able to serve any particular purpose, any other lab, any other clients. If you're serving someone, we'll be calling it as a servers, right? So with a high configuration, if you are able to support any other systems, then this is called servers. This is called servers. Now, all means usually we will be having the desktop, right? We will be having CPUs. This all things would be having some means low configured CPUs, and this will have the high configured. It will be connected to all these particular CPUs to this main server, which is having high capacity to store the data or anything. Means even if you wanted to store this one, you can't store here. So just it will push to server and it create a folder. And in this folder, for an example, student 1 details will be stored. Student 2 details will be stored. Like that, we will be create the logins so that all the people who sees the desktop here, but just all their data would be accessed from this particular server. So this is how the client server architecture will be designed. And I told you, right, whatever happens in this room, it stays in this room. Okay, I changed the quotation. It says whatever happens in Vegas, it should stay in Vegas. But the same thing here, whatever the thing happened in this room, it stays in that room. Means it is not connected to the internet at all. So these all connections are given it as in a LAN connections. So the data, everything will be stored internally here itself. So now all these students will have a different folder structures. They will be connected to this, and then they'll be having. So here we have some network topology, bus topology, star topology. So how to connect these all systems. I'll not get into those details. It will be into some networking classes. I'll not go into that. Just you need to high level. You understand that you should have a different clients which can connect to one single server which it can serve. And the presentation layer would be in the client side, and all the DB and business logic layers may be into the service. So that is what you need to understand from this particular pointer. If you go into the details, slightly it will be confusing. Slowly you will understand. Okay. You want some more details over on this, or can I move on to the further?
Go on.
Cool. The next one is the web application. The web applications. Now, how this particular web applications will be there is. Now you know, right? So you simply go to the Google, and in the Google you will start searching for something. So test automation. So now whatever you search, immediately you will be getting all this information. You search anything. See the name itself for the searching, they change the name for Google. So searching, it's say we are using to you as a Google. So means you can search anything, you'll be getting it. Now, without having this data, can Google display this? Okay, I'll ask you this question.
No.
You didn't have any photographs in your gallery. Can you open and see that particular photos in your phone?
Yes,
What's this?
No, sir.
we can see, sir.
How can you see? If you don't have any photographs in your gallery, how can you open and see the photographs in the gallery?
We can't.
No, sir, we can't see, sir.
See, if some photographs of the things are not there in your gallery, how can you see that? So
Okay.
you need to store something. You
If
need
we
to
stored
have
it
all
in
your.
somewhere, yeah, please go ahead. Sorry.
If you store the pictures and everything in your phone, then only you can see that, right? Now the same way, if you don't store it, you can't see it. Now, how we can see that back? The same way, the Google, what they will try to do is they will take some thousands and thousands of acres of land. They store all this data, all these images, all these contents. Now, whatever the things you are seeing it here, they will take that and then they will store it. And you see here, they give you the time. So previously it used to take 4 minutes. The first time when the Google was launched in late 90s, in that time, when the Google search was happening, it taken 4 minutes, 4 minutes to 6 minutes to search something when they started the Google engine. Now, in 4.3 milliseconds, means even it is not even a second, you are able to search your content. And you see how many content you have it. It's 13 crores. 13 crore results it is displaying within the span of 0.4 seconds. Even not even a second. 0.4 means 43 milliseconds. Now it changed. Now what it was happening is always the Google will store the complete data. Not only Google, any search engines will store that particular data here. Now this is what our presentation there, right? Here I'm typing this, I'm doing it. So my presentation layer is here. My searching, the searching algorithms, this is called the business logics, right? With this particular logics, this data may be distributed in different countries. You know, right? Always we keep the data backups. If you take in some photographs, videos, I will see that, hey, this is what, I'll have some data backup. Same way, they will be having the data backups because of the disaster recovery, which is called DR. Disaster recovery means, for an example, now I kept every data in New York. Suddenly there is an earthquake. I lost the complete data. Can we okay in India if I'm searching something, it is not working? No. Then I should have, if the New York database goes down, then San Francisco database should be up and running. Or it should be somewhere else in South Africa, so the data should up and running. So that is how they will take the data and they keep it into different geographical locations. And whenever we search for something, so this particular business logic algorithm, it will go to the nearest point, get that particular data, present it back into the presentation layer. If you see here, my presentation layer is different, my business logic layer is different, and the data which I stored is different. Dynamically, it will search for that and then get the data and present it to me back. And everything, this would be done on internet. So that is where, so three-tier architectures are called as, so web applications, and this is World Wide Web. www. World Wide Web. Throughout the world, it will go get it there. And as it is three-tier, because your presentation layer would be in a separate layer, your business logic would be in a separate layer, your DB would be in a separate layer. So then this is called web applications. And then this supports WAN network. And this is what the technology which they use, www, which is internet technology. And most prominently, we are trying to test our applications on the web applications. Now you understood, right, what type of applications we are going to test. So we're going to test our standalone applications or desktop applications. We may test client server applications and we may test web applications. But 80% of your testing will be performing on the web applications. Very rarely on the client server and then on the desktop applications. So now that's a reason we should understand what are the different type of applications, so that every application will have a different approach to test that. For an example, now I'm preparing sambar. So when I wanted to prepare sambar, then I have the separate ingredients. Now when I wanted to prepare some biryani, I have some ingredients for that. That ingredients are different. I can't mix up both the ingredients, right? So that is what you need to see it. That ingredients make the differences. So now when it is a desktop application, so this is how I need to test the web applications or desktop applications. For client-side applications, this is how I need to test it. So that's the reason this is very important for us to know what are the different type of applications we do have it and how we can test this particular different type of applications. That is what we wanted to see it over here. Okay, any questions still web applications?
No.
No, no, sir.
Okay,
No,
now
sir.
go for the network distributed applications. What do you mean by network distributed? The name itself, it was saying that network distributed. Example, now when we open this one, you see here, it comes as Amazon in. If I open this one, it was not allowed me to go. You see here what it was trying to say me.
Amazing.
If I it was coming to the same Amazon, but you need to observe one thing. It was displaying me in dollars.
It's showing
Means
dollars. Yeah.
this is US. Always you remember that. Now, for an example, I'll give you this example. This is my source and this is my destination. When I wanted to reach this source and destination, I have terrific traffic here. What I'll try to do, I'll take an alternative way to reach this way or this way. And because there is full traffic here, I can't stay longer time here. I can't reach my destination within time. So if I take the another alternative way, so that I'll be reaching very faster here, right? Obviously, same way, every country will have that distributed network. Example, India, IN, US, and UK, United Kingdom, MY, Malaysia, HK, Hong Kong. So now if you see here, Amazon.India, Amazon.UK, means that's the reason when I given US, by default, it given me dollars. If I given in UK, it given me in pounds. What it would do is, it reduce the traffic, means whoever stays in India, all those information will go to Amazon.in only. And whoever there in Amazon UK, it will go for only Amazon.UK. And whoever there in US, all the requests from the UK people, it will go to Amazon.UK or US. So we distributed even Google.co.in, co.in, and co.us, co.my, see, they differentiate because you just imagine that there is only one server, google.com, from different countries. There are some crores and crores of people accessing the Google. The speed will be very less for them, right? Now what they have done, hey, if you are India, you hit this server. If you are from UK, you hit this from server. And if you are from US, you hit this server. Or you are from Hong Kong, you hit this particular servers. So this is how we give that information so that the people can hit to this respective servers. Obviously, right? So this is how we have been distributed this particular network accordingly so that the people can hit this particular service accordingly and then they can reach and then get the data as quickly as possible. Because we don't have the patience, right? So if you are, you know, the Indian tendency, if you are not able to open any website within 14 to 18 seconds, we have the tendency to broke your mobile phones. So that's our tendency. And you know, right, if it means because of 4 seconds delay in Amazon great sales, there is a loss of 100 million rupees. Delay of 4 seconds. So time matters a lot. Time matters a lot. So that's the reason now every company will have, which are the huge user base companies, they will have multiple servers. So, you're getting from India, you use this Indian server. You're getting it from UK, you use that server. So they have been distributed the network based upon the traffic. So when you have that particular traffic, they will be distributing that particular traffic accordingly to base the country wise, and accordingly they can access those particular servers. So this is called network distributed applications. Yes, we will be testing the network distribution applications. In terms of performance testing, if you're performing this one, always you'll be testing on this particular network distributions. Last but not least, on the mobile apps. I think no need to give me more information on this one. So people might say that, hey, this may falls into the web applications or my standalone applications or many things are there because it's a combination of all these things. That's where the mobile apps are specialized. Okay, so the mobile team, can you please go on mute? Team, can you please go on mute? Okay. Fine. So this is how the mobile applications will be taken care, and all these particular mobile applications will be combination of one-tier architecture or three-tier architecture. We will have it. Some mobile applications, for an example, if you have mobile app calculators and all, those will be fall into the one-tier architecture. And something like Swiggy, Ola, these things, they will be distributed. They will be into the web applications. Means they will be having the presentation layer here, and the business logic layer will be in somewhere, and the data will be in somewhere else. So this is that's the reason it was not classified into anything, but it would be having a hybrid impact of one-tier architecture and then three-tier architecture. Very rarely the two-tier architecture. I didn't see any applications with the two-tier, but one-tier architecture and three-tier architecture will be combination of this particular mobile apps. Because in your mobile apps, probably you might be seeing something, some particular standalone applications will be there, and web might be there, or like most of the things are your web applications included into the mobile apps. Like we've seen it, right? Ola, if you wanted to book, the presentation layer will be yours, and the data will be stored somewhere else, and then the business logic will be stored somewhere else, and then it can be called back. So that's about the mobile apps and the network distributed or web applications or the client server are these things. I told you, right? If you don't understand what type of application it is and what is the technologies that they have been used, you can't test them. It is like, I don't know where to go, but I'm going. But if you have a strong goal, hey, I need to reach this one, then you can go there and do the testing properly for this. So this is one of the most important thing, which application we are going to test. Whenever you're going for a testing or whenever you're going for a company, for an organization. So when the first question you should ask is, what type of application is this? Because if it is a web application, the strategy of the web application is will be different. If it is strategy of desktop applications, that will be different. So the basic question you need to ask, what type of applications you have it? It's a web application or desktop application or mobile applications. So that you need to know. So based upon that, the testing of that particular application will get changed. So that's the reason. So first we have been started with this particular. Okay. So tomorrow, what I wanted you people to do is, you need to go through the SDLC. So what is this SDLC and what are the different phases of this one? So what we will try to do is, into this particular SDLC, what are the roles involved into the IT industry? So that we will be trying to discuss in that particular tomorrow's session. Guys, I seriously say that if you guys are not following the sessions and if you're not able to respond, so we will not be able to continue on the sessions. As I told you, I don't want an individual performer. I want